All right, we are going to solve some exponential problems using a logarithm, and we can do that because exponential and logarithmic functions are inverses. So when we look at letter A, we see a base of 10, and that should prompt us to use common log. So when I solve this problem, I need to do the same thing to both sides. So on the left-hand side, I'm going to write log 10 to the t power. And on the right-hand side, I'm going to write log 9. So we notice here that the word log goes in front of whatever was in the equation. If you like, you can put parentheses around, but you don't have to. Now, on the left, I have log and I have base 10. These are truly inverses, so they cancel each other out, and I'm left with t. On the right, I have log 9. And some of the problems in your homework will ask for the answer with the logarithm, so this is the answer. Other problems will ask you to give the decimal approximation, so you'll type log 9 in your calculator and you would get 0.9542. So very straightforward. Really nice when we have a base of 10 because we have the common log that's the true inverse. So let's take a look at example B. For example B, we have a base of e. And with base e, we want to use natural log. So this time on both sides of my equation, I'm going to put ln for natural log. So on the left, I have natural log of e to the t power. And on the right, I have natural log of 5. And again, we have a scenario where we have true inverses. So the natural log of e truly cancels itself out, and we have t is equal to the natural log of 5. And again, some of your homework will be happy with that answer. Others will ask you for a decimal. So I type this in my calculator, and I get 1.6094. So we're ready for part C. So in part C, we have a little bit more complicated equation, but still not bad. When I look at this equation, I'm actually going to rewrite it so that I can see all the parts. I have 3 times 4 to the t power is equal to 15. So whenever possible, I want to simplify before I use a logarithm. So I'm going to simplify by dividing by 3 on both sides of my equation. So my 3's cancel here. I have 4 to the t power is equal to 5. Now I have an exponential equation, so I know to use a logarithm, but it's not base 10 and it's not base e. So we truly could pick which logarithm to use, but the reason why the one is called a common logarithm is because it's commonly used. So I'm going to put log on both sides. So I'm going to take the log of 4 to the t power is equal to the log of 5. Now this time it's not as simple as it was in the first 2 examples. Log of 4 is not a true inverse. It does not cancel out. So I have to use the power property. The power property will allow me to take this exponent and move it in front of. So now I have t times the log of 4. And that's because when we have a power to a power in our power property for exponents, it's multiplication. And this side is still just log 5. Now I can solve this exactly, or I could convert to decimal. So I'll practice solving exactly on this one. So I'll divide this side by log 4. Cancel these guys out. Divide this side by log 4 as well. And so I have my answer. T is equal to the log of 5 divided by the log of 4. When I go to put this in my calculator, if I want a decimal approximation, I have to make sure to close the parentheses here on top to get a correct decimal approximation. So my calculator will open a parenthesis, I have to close it, and when I put that in my calculator, I got 1.1 0.16096. And you can round according to the directions in your homework. So that one, definitely a little bit more work because we did not have the base to match, either the base of the common or natural logarithm. Still could use the logarithm to solve. So let's take a look at part D. So in part D, I have a base with an exponent, so truly an exponential function on each side of the equation. So there's nothing I can do to simplify that. So I'm going to have to start out with the logarithm. I'm going to use the common logarithm on both sides right from the get-go. So on the left I have log parenthesis 6 with an exponent of t minus 1. And on the right-hand side I put in log, and this time I have 4 with an exponent of t plus 2. Now, just like the previous example, I don't actually have a true inverse, so I have to use the power property. I'm going to take this entire exponent down to the front. So that gives me t minus 1, I'm sorry my handwriting's getting a little messy there, times the log of 6. I'm going to do the same thing on the other side of the equation. So I'm taking this entire exponent, moving it down in front because of the power property. I'm allowed to do that. So I have t plus 2 and I have log 4. Now, this time when I solve through this problem, I'm going to actually switch to the decimals because it's a little bit easier. So on my calculator I type log 6, and so on this side I have t minus 1 in my parentheses, and then log 6 is approximately 0.7782. On my other side, I have t plus 2, and then I type log 4 in my calculator, which is approximately 0.6021. Now, because of this parenthesis and the two terms inside there, I need to distribute, so I'm going to take this over to the t and also to the negative 1. So I have 0.7782t minus 0.7782. On the other side here, I also have to distribute, so to the t and to the 2. And so that gives me 0.6021 t plus, and I just multiply these out, 1.2042. Next, I just have to sort and combine like terms to finish solving this equation. So I'm going to subtract this t from both sides, so minus 0.6, it's kind of a mess there, 6021t, and I have to do that on both sides. These guys cancel. On this side, I have 0.1761t. Then I'm going to add this constant to both sides, so plus 0.7782. Those guys cancel. Have to do it to the other side, so plus 0.7782. And I get 1.9824. So my last step is to divide on both sides, so I divide by 0.1761. These cancel, and I have t is equal to 11.9824. 0.2572. So we'll save the last one here, which is another complicated one, for our next video.